Well, it's nice to see you all. Well, actually, I can't see you, but I'm happy to be here to talk a little bit about the different families of rocks. Those would include sedimentary, igneous, and metamorphic. Okay, we're going to talk about how these are generated and some of the transformations that take place as one rock can become another rock in response to exposure to the surface environment of the earth, where weathering and erosion and transport and deposition can take place, or by burial, where we can turn sediments into sedimentary rocks, and we can turn igneous and metamorphic rocks, igneous and sedimentary rocks into metamorphic rocks. And if we melt things enough, then we create a magma and we can get igneous rocks. Got to keep that mask up. So let's talk about sediments to begin with. And when we look at sediments, we look at the grain size. And so here you can see very fine grained sand. And so this is a grain that you can barely see, but it's a product of physical abrasion of the pre-existing rocks. There's a coarser grain material, and so actually there's a mix. There's some really fine grain material down here on the bottom, but some coarser gravel bits. And so this has got a mixed grain size. And finally, we get to pebbles. And so, yeah, you can see these are another product of the weathering process. And also these have been transported a bit because you can see they're somewhat rounded on the edges. And so as materials go cascading down hill slopes or in streams, you knock the rough edges off, and that gives you a lot of rounding. So we've got three different sizes of sediments. How can we put those together to make a rock? Well, we can compress them, which will lead to compaction, and we can cement them. So we have compaction and lithification. That gives us a sedimentary rock. Fine-grained sedimentary rocks become things like shale. And so this is actually something between a shale and a siltstone. The difference being that the shale is made out of clay-sized particles, and the siltstone is made out of silt-sized particles. The difference between those two is about 4 microns in size, and they're all less than 63 microns, which means you can't really see individual grains. But notice when you put these together that you get a nice layered look. And so you lay down one layer and then another layer and then another layer. And the little grains are actually flat plates. And so as they settle out, they tend to lie on their flat side. And as a result, we get planes of weakness that run through this rock that give us nice layering when it breaks. This will, of course, be important if you have a hill slope that's inclined, because this kind of rock can easily fail on a hill slope. So, fine-grained shale. A little coarser, we have a sandstone. So, you feel that? Oh, it feels just like sandpaper. And you can just barely see the grains in this sample. You notice there is a little bit of layering. You can see it maybe better on this face. Mm-hmm. And so the layering may be a little subtle, but if you look carefully, you can find it. And the key giveaway for a sandstone is it feels like sand. Now, those bigger cobbles and pebbles and sometimes little boulders may wind up in a rock called conglomerate, where we have a mixture of grain size. And so you can see that these fragments in here are more angular than round. And so that suggests that maybe the source for this material was quite close to where the rock was cemented together. And so we call this rock actually a breccia sometimes, because it's angular fragments. but greater transport would lead to greater rounding, and both these rocks would be called conglomerate. So those are what we call detrital sedimentary rocks. They're made from sediments that were formed by breaking up pre-existing rocks into fragments of various sizes. We can also make sedimentary rocks from chemical precipitates. One of those could be something like halite. Notice we talked about this when we discussed minerals, and you can see this beautiful example of halite, nice crystal form, and if you break it, you'll get the same appearance because you've got these three planes of cleavage. And you can always tell this as well by tasting it if you're bold. Looking somewhat similar, but slightly different. Again, here you can see the crystal faces are a bit inclined to each other. And the other thing about this one is you can scratch it with your fingernail. And so, see, that doesn't rub off. So either I've got incredibly strong fingernails, or this rock has a hardness less than 2, or of 2 or less, and indeed it's gypsum. And so both this halite and the gypsum may be the dominant mineral in some of these chemical precipitates. And so they're mostly monomineralic. Another sedimentary rock we can make by taking fragments of shells. Here's this is actually often called a coquina. You can see the little fragments of shells in there, but it's basically a limestone because it's made of calcium carbonate from those shells. And here's one that's a little more massive. This is a bit more common. And how do you tell you have calcite? Well, 2 ways. One is you can test it with acid. We'll do that in a minute. And the other is that you can check its hardness. But before I get to that, I want to show you one more chemical precipitate. And this is a sample of chert. Now, you'll find this often as little nodules included in your rock sample, but sometimes you'll have something that's more monomineralic. And this is made of basically quartz. It's silicon dioxide. And quartz, as we know, has a hardness around 7, whereas calcite has a hardness of 3. Let's check the hardness. And so we have a handy dandy piece of steel. And so first we'll take this limestone, run it across, and there's a little bit of powder on there, but basically we can't scratch it. Whereas we take the chert and so you see that little scratch there?
Yeah.
Does that show up in the camera?
Yeah.
Great.
Yeah.
Okay, so clearly the chert is harder than the limestone. And the second way we can tell these apart, let's hit the limestone with a little acid. And you can see that thing fizz away. Okay, let's try that with the chert. And nothing. Okay, so if you're using an acid, this is about a 5% hydrochloric acid. If you're using an acid that strong, be sure to wash off the acid or wipe it off so you don't get it on your hands. The final sort of precipitate, which is kind of an unusual rock, but it's useful to see what this stuff looks like. And this is actually very low density black rock. And this turns out to be a fragment of coal. So coal is simply organic material from trees and plants that was heated. And just like in your oven, when you heat food too hot, you drive the water out of the structure, you leave behind the carbon, and you have these black deposits. This is coal. Okay, an important energy resource, which hopefully we're going to stop using. Now, That covers then the sedimentary rocks. And so we see that we've got detrital sedimentary rocks. We've got chemical precipitate sedimentary rocks. The chemical precipitates are often largely composed of a single mineral. In the case of limestone, it would be calcite. In the case of chert, it would be quartz. And in the case of these evaporites that are made from evaporating seawater that has a lot of dissolved ions, we could get halite from the sodium chloride that's present, or we could get gypsum from the calcium sulfate that's present.